So today we're going to have an introduction to big data. So can you put your hands up in the audience, and I'm going to do my best to have a look if you're working with big data at the moment. Okay, so that's about a third of the room, and I'm blind. There we go. Right, so you have an impression. So a little story about big data to start with. You probably all know Google Street View. So when we were having these cars driving around, taking pictures so we could have this nice, there's a great story about how Street View actually started. I saved that for another day, but if you Google it and Google Larry and Street View and how it all started, I'm sure you'll find a nice story. When we were doing that, we were just basically trying to capture those images so we could create this nice experience. What we didn't really think about at the time was how much data we were actually capturing. So I think I'm going to move on to the next slide, and here we're going to look at what kind of information is already in that image. And obviously, in the years after Street View, when we started to supply information on which way we were routing the traffic and things like that, which signs, where the addresses are, what's going on. So there's all this information there. So this is quite a rich data set. And you can imagine that if you have this data, you can already start to do something very useful with it if you can somehow get to the information that's stored in there. So that's a little story to start with. So big data applications. Some of them involve a human and others don't. Okay, what does that mean? So let's think about an application that involves a human. For example, if you're running some kind of experiment and you're trying to see what users are actually doing. So you say, well, you know, if we give this feature, do we actually get some response from that? Is it proving to be successful? And so you're actually looking at their interaction. Others that might not necessarily involve a human interaction might be, for example, blocking fraudulent transactions. So, for example, we're looking at credit cards coming in, transactions, and we want to know which ones are actually, you know, valid or fraudulent. So we might build a model or something and actually start processing that data. And you can imagine how much data you might have coming at you as a bank with all these credit card transactions going on all the time. So there's a couple of examples of big data applications, or let's say use cases. And now we're going to look, today, we're going to actually look at 4 different tools that we can use from the from Google Cloud suite, which will actually help us do something with big data. So we're going to look at how we analyze data, we're going to look at how we can prepare data, we're going to look at how we can process it, we're actually going to look at some of the end results, how we can actually start using that in dashboarding, for example, and also how we might actually leverage the skills of a data scientist to actually interact with that data to create, for example, a machine learning model. So this is a little something to think about big data as well, because when you talk to people about big data, they say, well, you know, I'm not doing anything with big data. You know, I have a database, there's a terabyte of information in there. It's not a lot. But then let's have a think, like, what kind of data do you have actually at the moment? So there's the data that you analyze now, today, and that data is probably, like I just said, in a database. It might be up to a terabyte or something like that, and it's well structured, you know it quite well. Your business intelligence teams are probably working with it quite a lot, so you've got a good grip on what that actually is. There could be data that you collect, but you don't actually process or analyze. So you could be collecting logs from your website application, for example, server logs, which are telling you what things are happening, what users are clicking on, what page users start off on, and where they move to throughout that journey on the website, but you might not be processing that, for example. And then there's data that you're not even collecting. So maybe in those logs, you're only collecting at a certain level, and you're not actually keeping all of the information because it's too expensive to store or something. And then also, on top of that, there's data you can actually acquire from third parties. So what would be a good case in this? So let's say you're doing something with recommendations, and you want to get some information about seasonality. You know, what's happening with the weather, is there a correlation there? You're probably not going to go and stick sensors up all around the world. Someone else is doing that for you. So you'll probably buy that data, or find some way of acquiring it so you can bring it into your ecosystems and start doing so. So it's quite, as going back to that first image, when we took those photos, there's already a lot of information there. Once you find out the use cases and start looking at what data could be there and how you could discover that, then you can think more about what you might actually want to do with that data. So we're going to start off with some of the challenges, and the first one is hard to develop big data pipelines. So we're going to talk about a UI application that we've created called Google Cloud Dataprep. This is it was launched this year, And it's a tool that basically allows your analysts and data scientists to actually interact with raw data, to clean it up, to process it, and actually to get it into a database where they can start analyzing it. So one of the challenges, and before I joined Google, I headed up a business intelligence team for a number of years. And one of the challenges that the team would have, especially the analysts on the team, was when we didn't have enough development capacity to build pipelines, some of the analysts and some of the data scientists, they wanted to start, experimenting, creating models, coming up with some information to tell, their business users what was going on with the products and that kind of stuff. But because we hadn't processed that data yet, they didn't really, they won't be able to make those insights. So having some kind of tool where they can kind of self-service, where they can actually go in there and process that, look at that data, process it. And key to this is that once they've actually, had a look at that data and played around with a sample of it, whatever we create there, that we can actually apply at scale and use it to process all that data that they might want to use in the data warehouse for their next step, so the analysis or the data science. So we're going to look at two data sets. The data set at the bottom is ad impressions, and this is basically some data stored in the CSV file. And as the red highlight is highlighting, we want to extract some information there, which is the product ID. So that's something you might see on a web URL. Someone goes to a page and the product ID is there, but we need to get at that ID. The other thing that we want to do is we want to look at some transactions. And these transactions we're storing in BigQuery. And if you're interested in BigQuery, I'll probably say this again somewhere later in the talk, but if you're interested in BigQuery, stick around for the next talk, because Ismail is going to give us a great talk about BigQuery. So we will only be touching on that very lightly during this talk. But if in BigQuery, in this particular data set, we have some transactions. And what's actually quite special about these transactions is that we're storing, actually, in BigQuery itself, nested data. So one of the things that you can do with BigQuery is not just store your flat table, but you can actually have within each row a collection. So think about order and order lines, or a transaction and transaction lines. So we have a transaction with the different lines, with the transaction lines, and we want to get to and at the transaction line level, we're storing the product key, and that's what we want to get at. So what we're basically going to try and do in this data set, we're going to try to join the two together, and we want to create one data set where we can look at which ad impressions actually resulted in a transaction, and maybe we want to look at the time between those two or something. So we're going to attempt to do this now in a demo without actually writing any code. So that's the goal of Dataprep. So we're going to switch over to a demo. This is Cloud Dataprep. It's accessible via the Cloud Console. And we're going to start off. I've imported two data sets to save time. The top one is the CSV. And this other data set here, the scale 2, is our data set from BigQuery. So we're going to go to flows here. And here is where you basically create a new flow. So once you've imported those data sets, here's when you're going to start working with them. So we're going to create a new flow. Demo, please be kind. Okay, we're going to add a couple of data sets here. So I'm adding the CSV, and I'm adding the sales scaled data set. Okay, so here's the sales scale that's coming from BigQuery, and here's the CSV. And you can already see here, I dropped the CSV, but some action has already occurred. So basically what Dataprep is doing is creating recipes, and those recipes is basically what you need to do to cook your data from raw to something, well, cooked that you can start using. So let's have a look what it's already suggested. Well, it was a CSV, so it understood that it was a CSV, so it looked at the delimiter. So there's a certain amount of intelligence and machine learning behind this to actually do some of this stuff, and you'll see in a moment how powerful some of that can be. But it's already come up with a suggestion, you can see here on the right, so it's actually worked out the type of columns that it is. Let's go and have it edit our recipe for a moment. Keeping an eye on the time in the meantime. There we go. So what do we see here? We've basically got all of the columns extracted for us. You can see for each column, it's already suggested a data type. So this one is alphanumeric, this one is a number, and here we have a date time. And we've got the distribution of the data. So basically, the data set where I imported was a CSV in a cloud storage bucket. If there had been multiple CSVs there, it would basically be able to import all of those. And you see at the top here, this is quite a small data set, so it's just picking the whole data set because that fits quite nicely. But if it wasn't, you could actually, if it was a bigger data set, we could collect a random sample, so you use different sampling techniques to actually have a look at that data. But since we have all of it here, yeah, that's easy enough. So we can see here the distribution of the data, and so scroll and look at the different columns. And one of the columns here, the event time, if I look here, I can see that there's some data which is actually a little bit problematic. What is it saying? Let's have a look. So you notice all I did was click here on that data. So I just clicked on that little red mark. So Dataprep is really the kind of GUI where you have to just click around and it kind of works out what you're doing. So I clicked here on this red part because that looked odd to me. And it came up with a suggestion. It came up with several suggestions. One of them is that, so let's have a look at this one. This one here is saying, I'm going to delete the rows, so delete, where it doesn't conform to a timestamp. So there was a text in there, timed out or something like that. But actually, it's coming up here and say, well, the rest of the dates conform to this pattern, so let's use this pattern. And you can go ahead here and edit that if you want. But I'm quite happy with this, so I'm going to add it to the recipe. And over here on the right, you can see the little open recipe. And you see already those steps that it needed to do to go from the CSV file into the columns. And this new step that we just added to delete the rows, you can see that they're all here. So break the rows using a new line as a delimiter, and we're going to split into columns on comma. We're going to convert the first row to headers, and then we're going to delete all the rows where it doesn't match our date timestamp. So we have those, but I said we wanted to look at the URL, and we want to get that product ID out of there. So if we look here, here's that product ID. So what I'm going to do, as I said, you have to kind of click and show it what you want to do. So I didn't quite get all of the information there, so I'm not really good with a mouse on well, anyway. There we go. So I've selected that, and it's come up with some suggestions. What's it saying here? It's saying, do I want to replace PID equals 114, blah, 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 with empty string? Well, it's not really useful, no? I mean, it'll work for no, I'm not extracting anything. So let's try something else. Let's try to select another one at the same time. So I select another one, and now it's come up with a pattern that is asking me if I want to apply this pattern. If I just look here on the right, you can already see it's doing a good job of actually extracting that product ID. So let's have a little look what's going on. And you can see here it's looking for a pattern, but obviously the PID equals isn't part of my pattern. So I'm just going to take that part out. There we go. Put that down here. So I'm going to say it starts after the product ID. And now you can see in my new column, I have quite a nice product ID. So I can add that to the recipe. And the only other thing I'm going to do here is I'm going to rename this column to PID. That was the forced touch on my Mac if anyone uses Mac. Don't all laugh at once. Okay, so I've got my product IDs now. Let's go back and have a look at the other data set. So here I have the sales scaled, and let's see what we can do with this. So let's add a new recipe. And now we're going to go in and edit that. Right, so it hasn't done anything yet, but what you can see here on the sales order lines is I've basically got an array, and I want to do something with this array, so I'm going to select the whole column. There we go. And it's going to give me some options. It's going to say here, do I want to delete this column? Do I want to split it into 170 different columns? Nope. And here it has, do I want to convert these arrays into rows? Well, that looks quite good. So now I've gone up in like a kind of order of magnitude here. So I'm now at 35,000 rows. So I think I'll keep that as the first step. But now obviously I want to get to this data and start extracting it. So let's click on this one and see what it's going to suggest. So it's going to give me some options. And one of the options here is to split. Let's have a look what happens there. Well, that doesn't look very good. I should have some more. And now I've just clicked back. All right. Bear with me. This is the demo effect. So I'm quickly going to do that again. Okay, no, it had already done that for me. So I need to find something here that's going to actually understand these columns properly. Here. So I already had the right one selected, and I've just done that again. My excuses. Third time lucky. And I promise I will disable the 3-finger swipe on my Mac one day. Which is actually a promise I made after my last demo, but still haven't got around to it. I have another demo next week, so if anyone is in the audience, knows me personally, wants to give me a prod, that would be much appreciated. Right. Here we go. Using one finger. So it's already splitting those columns for me, and one of the things, I'm not going to keep all of them now, I just want to keep a couple of them. So I want to keep the product key. That's actually all I want to keep, so I'm just going to delete the rest of these. There we go. And I'm going to add that to the recipe. Just going to take a few seconds. Right, so you see now I've extracted that product key. So what I've done, I took that array of data, we broke that array into rows, we unnested it effectively, and we've now extracted the product key column, which is what we were looking for. So the next thing I want to do is join this data with the previous data set. So if I come down here and I say join, and it's going to ask me which data set do I want to join it with. And obviously, it's my ABC1. Why am I not seeing that? This flow, so there we go, that one. So I want to join it with that one. Previous selected data set. Okay, and the first thing I'm going to do here is look at the join keys. So the join keys, right, it's suggested a join, but it's not very good. It's not very good. So let's actually go and look at that and maybe change that around a bit. So let's edit that. We don't want to join on the sales order key. We want to join on the product key. And we were also looking at customers. So let's also join with the customer key. Hold on. Yes, that's good. And now give me one more. And in this one, I want to join the customer key with the user ID. And I'm going to save that. And now I can look at which columns I want. So obviously, I don't want all of these columns here because we don't need to have the user ID. And I'll keep the product key, I'll keep the customer key, I'll take the order date and the event time, and let's just take the total sales. And then we can add that to recipe. So I've now joined those two data sets together, and apart from going back and forth between my screens because of my sticky fingers, we've actually managed to join two data sets. We've done some quite complicated transformations. We've extracted product IDs. We've unnested data. All that's left for me to do now is to run this pipeline. So I ran this earlier because it will actually take a few minutes to run. So let's have a look at what that looked like. Let's go back to, so here's the Madrid next demo. You can see the same pipeline. And if you look at jobs here, you can see that I actually ran this yesterday. That was the pipeline. I click on the job ID. We can have a look at the recipe. We can also export there we go. So it will give me an overview of what I've done. And so basically what's going to happen when you run this job is going to create a Dataflow pipeline. And we'll look at Dataflow in a moment. And that pipeline will get executed in Google Cloud. So it can really scale to whatever size it needs to deal with however much information is coming at it. And at the end, we can actually send that data to BigQuery or back to a cloud storage, for example. Having in BigQuery would be super handy because then we could actually do some analytics and some dashboarding from it. But I hope this has already given you a good idea about actually what you might be able to achieve with Dataprep, just through actually looking at data sets, trying to understand them. And at the end, we're going to create a pipeline. And that pipeline, you can actually then run and then run it again. So you can actually have your data appended each subsequent time. So this should give you a good indication of what you can do with Cloud Dataprep. So we're going to move on. We're going to look at that particular job that we were looking at was actually about a batch job. We had the data, it was fixed, we had a CSV that was ready for us, all the data was already available for us in BigQuery from the transactions, and now we're going to look at how can we actually handle some data that's coming in as a stream. And again, we're going to be using Dataflow for this. So I mentioned Dataflow a few times in that last presentation. The Dataprep itself will actually create a Dataflow job, which is going to run to process your data. So what is Dataflow? And we're going to take a use case of streaming. So a few things about streaming. A lot of the good systems that are out there were built to they were designed to run on distributed systems. They weren't necessarily designed to be very friendly for developers. I mean, MapReduce is great. Google, we published a white paper back on MapReduce somewhere early 2000. It's a fundamental part of a lot of the products that we make at Google. Also, Dataflow, it's also behind BigQuery at a certain level. So it's a very important, let's say, programming model. But it's quite difficult as a developer, especially when you're working on small tasks or for the first time, to get your head around. And then we have some additional problems. We have batch, which we just looked at, which is really nice when everything is already there and you can actually take it, move on, and you know the whole data set that you're looking at is complete. So nothing's going to come at you later. You're not going to have data that arrives tomorrow because it's a batch. It's a complete set. So you know you're looking at the whole picture. In the case of streaming, that's not. I mean, you're just getting single events or, let's say, little groups of events that are coming at you, and you don't actually know if you've seen everything. You don't even know if everything's in the right order. So there's this whole notion of processing time and event time that can be quite difficult to wrap your heads around. So the first key component in this, and I actually should have put an architect slide in here, the first key component is actually getting those events in. So one of the things that we're going to use is Popsup. Popsup is basically message queuing. It's a global system. You can send literally millions of messages per second to the system if you need to. It will guarantee you at least once delivery on any subscriber. So it's called Popsup, so publish and subscribe. So you have a publisher and you have a topic. So your publisher is sending something to a given topic. And all your subscribers on that topic, you can have as many as you want as well, will sit there and listen, and they will receive messages either by a push or a pull mechanism. And this is like, think if you're going to create any pipeline downstream where you're actually going to be handling streaming data, Popsup is a good place to actually start buffering that because, if you turn that system off or it's not running, you still need to be able to get at the data. Yeah? So, or when you want to start up again, you want to be able to pick off where the data that you haven't yet processed. So having a buffer in between is very important. A little bit about the event and processing time. So in an ideal world, we would see that diagonal line there, that diagonal slope, that would be perfect, Every time something happens, we can process it instantly. In reality, this is not the case. I will give you an example now. So in this example, before I explain what Apache Beam is, in this example here, we have event at time on the x-axis, on the y-axis, we have processing time. And again, we have the dotted line, the diagonal line, which is the perfect line. So the number 3 is almost on the perfect line. Imagine these numbers represent scores on a game, and the only thing that we're actually interested in doing is for this particular user, and let's just say all this data is from one user, we're interested in actually calculating his score and sending it back to him, so, or putting it on a leaderboard somewhere. So every time we get an update with how many points he scored, so we want to be able to process that and, represent near real time on a dashboard his score. So 3 is really nice. The event time and the processing time are very close to each other. This doesn't really happen very often. So what we do with Dataflow is we try to create a heuristic watermark which represents this kind of relationship between the event time and the processing time. But it's based on the information that it receives, and it's not going to be based on things like if something comes much later than I expected. So score 9 here came really late. It happened at just a little bit after 12:01, and we didn't process it until 12:08. So it came really late. In fact, many different scores that we received all the way up to this score here, in the meantime, we actually processed those before we even saw this one come in. So that's problematic. What we've done here, so Apache Beam is the open source project for Dataflow. Dataflow is our managed service to run Apache Beam. So much like TensorFlow is an open source project for machine learning, and you can use Cloud ML to run your machine learning projects, do your training or to do your predictions there. Dataflow will give you the same ability to take your Apache Beam processing. So it's a MapReduce-like, but the important thing about Apache Beam is unified batch and stream. And what does unified batch and stream mean? Basically, we're giving you the semantics to be able to deal with data regardless whether it's batch or stream, so you don't need to go and create 2 different pipelines. And then the important part of being able to do that is to be able to, first of all, window your data. So do you want to window in fixed windows, in session time? Do you want to window in sliding windows, for example? And also to be able to deal with data as it arrives late or early. And in this particular case here of 9, we're dealing with a piece of data that arrives late. So that data comes in late. We fire a trigger and say it's coming late. And in that programming model as well, we also tell it, in our window, if data comes at us late, we would also like to still be able to, we keep all the data we have in the window so we can accumulate, and then we will add that and we will emit an update of the score. So you don't have to do it like that, but that's just an example of how you might want to do it. So let's move on. So for anyone that's visited the booth on the Instant Insights, this might already be familiar to you. This is the architecture I was just speaking about at the beginning. So Popsup, we've got events happening. Here taxis are driving around, and we're going to use Dataflow to process that information. And as that information is processed, we're going to do 3 things. So all the solid arrows here are actually streaming lines, and all the dashed arrows, these are batch lines. So there are 3 things going on in this pipeline. The first one is we're taking all the data that comes at us, all the events that we receive, and we're sending them straight to BigQuery so we can analyze them. By doing that, all the data that we already have in BigQuery, so our data warehouse, all the data that we already have there for this particular table, and all the data that's being streamed in, we can query. So we have the possibility to do real-time querying on the data and historical data as it comes in. And that's good because then we can use something like Dataprep to analyze the data. We'll look at some other stuff in a moment. And once we've done that, we could use that data, for example, to retrain our model. And here we would train a model in TensorFlow, in Cloud ML, the service I just mentioned. And once that model's ready and been trained, we could release a new version to our serving part of the Cloud ML space. And you can have different versions there, which enables you to do like A/B testing on models. And what we're going to do in this particular example is we're going to make a prediction on how likely the users in that taxi, so what information do we have? We have where the trip started, where the trip ended, how long the trip is taking so far, and the number of people that are in the taxi itself. And we'll make predictions on that, or on how likely they are to respond to a given advert. So one of those adverts might be, and you can see at the example if you want to see more of this at the booth, but one of those examples might be 3 people driving in a taxi to the airport might be interested in having, sushi before you fly. Not taking responsibility for the adverts. Another example might be someone driving from the airport into town as a single person, and they might want to say, well, would you like to visit this wine bar? Because we know this wine bar is very popular with single people that just come into town, for example. So that's the second leg of this pipeline. Now we have this information still coming in here. So we've sent some of that, we've sent a copy of that information to the data warehouse, and we're sending another copy of that information. Well, we're calling the data here to make a prediction, and once we've made that prediction, we will send them like the recommendations for the adverts. And the last thing that we're doing is we're sending a small aggregate of that data, so we're aggregating that data that comes in so we can produce a heat map. So think about like a dashboard that you might have at the control center to kind of show what's going on at the moment. So how many taxis are driving around at the moment? Which locations are they driving around in? You know, if you're having a conversation with a potential client, you can say, well, look, this area is really popular with taxis. Would you like to have, there could be a way of actually trying to promote your advertising space from there. So these adverts will be obviously displayed on a little screen in the back of the taxi as they're driving around. It's a very modern taxi. Okay, so I'm going to just show you Dataflow very briefly, because I've got to speed up a little bit. It's not like me to talk over time. So this is the same pipeline, so I'll just show you a few features here. One, this is the data coming from Popsup. It's being read from Popsup, and we're sending it to BigQuery, and you can see this is running at the moment. So again, go to the demo booth if you want to get more details on this. And the other branch I want to show you here is the ML call. And one of the useful things that you might want to do here is just open up the logs. And I've just selected the ML call. So just give it a second for this to populate. And you can see here that there are requests being made and there are responses being given for the different predictions. So this is online, it's running at the moment. And please have a look. So that was Dataflow. So we just looked at a bit hard to develop data pipelines. A good thing just to reinforce, everything that we've looked at the moment is completely managed. There are no computers for you to manage yourself. If you run something in Dataflow and you put the right configuration, like you use as many machines as you need to, it will scale up and scale down to do whatever it needs to do to get the job done. The same with BigQuery. The Dataprep is creating a Dataflow pipeline in the background. And Popsup is a completely managed service, and you're just not concerned by any number of machines or anything there. It's just the throughput that you want. So this next part is about hard to scale and operate on big data applications. So let's have a look at some of the challenges. These are some of the challenges. I'm not going to read them all out. But basically, this is where you want to be. You want to spend your time on insights and analytics. You don't want to spend your time on doing performance tuning, resource provisioning, all that stuff. So let's move on. Let's look at those three applications again. I just basically foretold this slide. But Popsup for ingestion, Dataflow for processing, and for analysis, BigQuery. Again, no sharding, no capacity guessing, no idle resources, etc. These are managed services. And in that key, so BigQuery is using standard SQL notation. So you don't have to go and learn a new SQL dialect. There are a few add-ons for unnesting data, for example. I'm sure that we talked about in the next conversation. I can show just that very, very briefly here. So here is a row in the table, and here are the nested rows, let's say, the repeated rows. So we have a few extensions to deal with that. And Dataflow, that all-important processing part, because this is where the magic is happening, where you're actually transforming your data and filtering it and applying all sorts of complicated stuff. This is where your business logic is. You can write that in Apache Beam. That's open source. You can run that on Spark. You can run it on Flink, on your own Hadoop clusters as it's running at the moment. Or if you run it by us, we'll run it in a managed service, and you won't have to worry about all those things on the right. This line here is basically showing a little bit about how much Google has been involved in open source and big data technology. So things like GFS and MapReduce, these are two white papers from, I said, early 2000, there you go, 2004. And these were basically white papers that were really kind of instigated the whole Hadoop conversation, let's say. Dremel, our externalized version of Dremel, is BigQuery. Basically, we built BigQuery because MapReduce wasn't fast enough, nor was it friendly enough. So one of those things, we want to spend time on insights. We don't want to spend time writing complicated pipelines if we don't have to. So with BigQuery, you're just using standard SQL, and you can run literally a petabyte query in a couple of minutes. It's going to be an expensive query because there's a lot of data to process. But if you want to run a petabyte in a couple of minutes, it's completely possible with BigQuery. So another challenge is silos in analytics. Silos of analytics. There we go. So how can we avoid those? Well, we can avoid those like we avoid most things by separating out responsibilities. In this case, separating storage and compute. So we have, on the lower line here, we have storage options. So cloud storage, object storage, files. We have BigQuery, and BigQuery in this case, when we're talking about BigQuery storage, so BigQuery has two parts, the processing and the storage, and BigQuery storage is really optimized storage. It's column optimized storage, so you can really get great performance from your queries. And the last one here is Cloud Bigtable. This is our own internal version of what external version, for example, in the Hadoop community, you would see something like HBase. If you, Bigtable itself isn't open source, but we do supply an API which is HBase compliant. So if you would like to move from Bigtable into HBase to running your own HBase cluster in the future, you could do that completely, and we have an API which means that how you communicate with Bigtable will be the same how you communicate with HBase. So that's the storage options. On the top line, we have the processing. So we just looked at Dataflow. BigQuery analytics, so this is basically the part of BigQuery where you're actually writing queries and processing your data. And Dataproc. I don't have time to speak about Dataproc today, but Dataproc is basically our Spark and Hadoop, the Google Cloud way. You can spin up a cluster in under 90 seconds. You can basically start thinking of MapReduce and Spark jobs and Hive jobs or pig scripts in the terms of a job as opposed to a cluster. You're built by the minute. Because we can spin up and tear down so quickly, it completely changes how you look at that. So if you're running Hadoop at scale and you're interested to know more about this, please contact any of us, and we'd be happy to, or any of our partners would be happy to talk you through that. In all three of these cases here, what we're basically doing, we're given the options to be able to interact with any of these processing units with any of the storage units underneath, as you can see. So that really gives you the ability to kind of separate where you're storing things and make it available for all your different processing environments. Cloud ML Engine, I said this is our managed service for running TensorFlow. I'm just going to leave that there. That's kind of a bit vague, isn't it? But what we're basically trying to say here is that what we're doing on the data processing side, we're doing on the machine learning side as well with TensorFlow. So if you think in this discussion, TensorFlow is taking the same spot as Apache Beam. Open source projects, you can run the way you want. If you want to run them by us, we'll make sure good security, good performance, good cost. Then we have a managed service to actually help you do that. And now we're going to look at some of the data science tools that you might need. So the first one we're going to look at is Datalab. Quick hands up again if you've used a Jupyter Notebook or Zeppelin or IPython. So great. That's a fair number of hands. So for those of you that don't know it, a Jupyter Notebook is basically a way in which an analyst or a data scientist might want to write his code in Python or R to actually, start processing data, whether that's actually doing some analysis or it's creating a machine learning model. It's a really interactive and collaborative way of working. I was showing we have a managed option, which is called Datalab. And the nice thing about Datalab is it's based on IPython notebooks as well. And it basically it brings all of the connections that you need with all the Google products to one space. And it has some more collaboration options. I will show that in a second. So the first thing I need to do is, let me just close this. I'll do it from scratch. So if I go to my VMs, you'll see I have a VM here running called Big Data Workshop. I'm going to use the Cloud Shell, and I'm going to connect to this VM. Just a few seconds. There we go. So I'm going to call Datalab. And if you didn't have a Datalab instance like I have here, you could just do, instead of writing the next word, connect, you would write create. You can also give a machine type if you want to have a slightly bigger machine type. Worth noticing here, the machine type that I used is actually too big, so it's actually giving me a recommendation. So all this stuff that we tried to do outside of Google Cloud to offer you that ability, we tried to do inside Google Cloud as well, and obviously other Google products. So here's giving me a recommendation based on my usage that I could use a cheaper machine and save some money. So that's good to know. But here I'm just going to connect. So Datalab connect, and I just need to type the name now. So Big Data workshop. That will set up a SSH tunnel. Okay, and this little web preview here, I could select there and actually click to open page. So I already have it running here. Once I click and open, I basically get my data. This is kind of the menu page, and here is a notebook. You see connection failed because at the time it wasn't connected. If I just refresh this now, you'll see that it's all fine. And we're going to run very, very quickly through this notebook because I do want to show you Data Studio as well, and I've got 4 minutes and 48 seconds left. Here we go. Please, can I have 5 more? So here's basically, nice thing about this is that you can combine markup with actual work that you're doing in different cells. This first cell isn't too interesting. I'm just importing something. But the second cell is really nice. The second cell here, I'm going to actually ask me to describe one of the tables in BigQuery. And you see this 2% sign? The language that I'm using here is Python. If you see these 2 percentage signs, that's basically telling Datalab this is a magic cell. So if I use 2 percentage lines, the whole cell is magic. If I use 1 percentage sign, then it's just that line is magic. So it's basically say, go use the plumbing that's already done in the background, and that plumbing will allow me, in this case, to connect to BigQuery without having to write all that stuff because it's in my project, I have the right permissions, and it will describe the table for me. So there we go. It describes the table, and I get a quite nice description about all the different columns that I have. And here's an example of some of the nested data. So here I have hits, and under hits I would have actually repeats of this. I'm going to go down and do a little bit of querying. So I'm going to go to the bottom in interest of time. I'm going to run this query. And then basically what I've done by running this query here, I haven't actually run it yet. I've just told it to get ready. And I basically say, when I call conversions, run this query. So here we're going to run the query, and I'm actually going to say now execute and put show me the data. And it's going to show me the data. But I would like to do something a little bit more useful with this to make it a little bit more visualized. And I'm going to use a SAN key. So here I'm running a SAN key. And this data set that we're looking at is conversion on analytics. So it's very similar to that first use case. It's like, okay, given that you start off on this page on the website and you move to, we want you to be here, so let's after the shopping cart, what's the conversion, for example? And here we can see if with a SAN key, if I start off at the product page, so many are abandoned and so many are completed. So it gives me good visual representation. If I start off on the home page, the proportion between abandoned and completed is slightly different. That seems to be working slightly better, but more people are actually landing on the product page than the home page. You can draw your own conclusions, but this is a really good way of interacting. One thing to mention is that when you run Datalab, it's already tied into Git, so you have ungit here, and ungit will actually allow you to connect to the Git instance, which is running on your Google Cloud project, or if you want, you can connect to a GitHub instance. And I can actually use this to check in the work I do, so if I'm trying to share this with multiple people, they can all work on that and receive the latest updates. And all of that's out of the box, so once you just basically do that Datalab create and give it a name, you can start working in Datalab, use that machine, and people can work together to make useful things and share that amongst each other. So that's a good way for a data scientist or an analyst to actually explore data or start writing a model. And the last one I'm going to show, so I'm actually almost on time, is Data Studio. So when you run a query on us, a BigQuery, we charge you for the query, the size of the query, and we charge you for the storage. We have a product which is similar to other dashboarding products out there. It's a little bit more simple, but it has one amazing feature, that's in my personal opinion, has 2 amazing features. First of all, it's free. So you can actually use this, and you can give it to as many users as you need to. They can all work together on that, and you're only paying for the queries that are running. So here is an example of a dashboard being created. And the first thing I'm going to show you is in view mode. So this is what the dashboard would look like if someone was actually looking at it. You can select the date here. You can look at what's going on here. This is all kind of standard dashboard stuff. I will show you very quickly one thing. And that one thing that I want to show you is collaboration. This is the part I personally think is amazing. What we do at Google with things like G Suite, so with sheets and documents, if you've ever used them, the ability to work together at the same time on a document, we also have in our dashboarding product. So you can come into this product, and I've actually got 2 screens running here. So at the moment, this other user here, you can see that's not me, that's Google account Instant Insights, and here that's, well, you can see a nice photo of me, so that's me, obviously. My name's Robert, hi. So this user here doesn't have the ability to edit it. So I'm going to change the sharing rules. Let me have a quick look. So if I go share the report, I can see here by advanced, I've already shared it with the other user, but they can only view it. If I say that they can edit it as well, save the changes, click done. You can see now, if I refresh this page, that I can also edit. Come on, there we go. So I can also edit on this page. And I'm out of time, but one moment. I'm going to add an extra page to this report. I've just done that. I'm going to add a new chart. Let's take a bar chart. Where are you? Here. And add a bar chart, for example. It's already going to come up with a suggestion. I'm going to try adding it again. Okay. Demo effect right at the end. Yay. Well, while you're refreshing, let's go to this user. Maybe you're okay. So let's add a bar chart. There we go. I added a bar chart. It's already given me a suggestion. Obviously, you can go here and do all the kind of stuff that you would normally do with a bar chart. And you can see here in real time that this user it can also start working on that bar chart. So the only thing I'm going to do here is to say style, and I'm going to say make it horizontal. And if I go back, it's horizontal. So there are two users working together, creating the same dashboard. And with that, I'll let you get ready for your next talk. Thank you very much.